Welcome to PyData 2021 for my talk for Doris Lee's talk. Doris recently finished her PhD at Rise Lab and School of Information at UC Berkeley. The focus of her research is design tools that make data exploration and visualization easier and more accessible. During this time, she developed several data science and visualization tools aimed at accelerating insight and discovery, including Lux, a Python library for accelerating and simplifying the process of data exploration, which is the focus of this talk today. Since this is Doris's time, I'll let her take off.
Cool. Hi, everyone. My name is Doris Lee, and as Steven mentioned, I recently finished my PhD at Berkeley, where I worked on building tools that makes it easier for people to visualize and explore their data. And I'm super excited to speak at PyData Global today to share our work on Lux, which is a tool that automatically helps you visualize your Pandas data frames. So many of you at PyData Global probably already know about Pandas and how it's a tremendously popular tool for data analysis. And Pandas is really awesome because it comes with this intuitive and convenient set of APIs to let users play around with their data and get quick interactive feedback. And Pandas is especially useful because of this convenient set of utilities to help data scientists load, clean, transform, and analyze their data. And so when you're exploring your data, visualization is also a very easy way for users to ask questions about their data and learn from the interesting patterns and trends that emerge. And in terms of how this is actually done in practice, this is similar to what we see on the left-hand side here, where data scientists would write Pandas code and use some additional libraries in a Jupyter notebook environment to be able to experiment and explore their data. But even though the Pandas data frame comes with a very wide range of functionalities and operations, it's often not easy to figure out what exactly you need to do and what is the steps of analysis you need to get to these insights. So let's take, for example, let's say a simple task such as visualizing this bar chart. There's still a very high effort that is required to visualize your data programmatically. So first, for example, we need to think about what this visualization should look like, what graphical encodings and mark we should choose. Is it going to be a bar chart? Is it going to be a scatter plot? And then we also need to think about how do we process this data correctly to plot this visualization? And then once we figure all of that out, we need to translate all of these specification details into code. And on the right-hand side here, what I'm showing is examples of just two examples of the amount of code that is necessary to generate a single visualization in that we see on the left. So this is based on Matplotlib and Plotly, which is two very popular Python visualization libraries. So oftentimes what happens is the sheer amount of programming effort that's required for visualizations often hinders data exploration. And this is true, especially in the early phases of data exploration, where you're just kind of getting an overview of the data and the users have a vague idea of what they're looking for in terms of insights. And so to address these pain points, what we've done is we've developed a lightweight visualization tool on top of the Pandas data frame called Lux. And the goal of Lux is to make it easier for data scientists to explore their data by automatically recommending useful and relevant visualizations to the users. So without doing too much talking, what I'm going to do is I'm going to jump into a quick demo to showcase some of the capabilities in Lux. And if you're interested, you could also check out this website, which has the full notebook for the demo. But I'm going to screen share and show the notebook here. OK, so what I have loaded up here is a Jupyter notebook with some commands in Lux and with Lux loaded. So in order to use Lux, all you have to do is you can do this import Lux statement alongside your import Pandas statement. And when I load in Lux, what I can do is I can use any of the familiar Pandas API that I'm already using. So for example, in this case, I'm using pd.readcsv to load in a data frame. And so far, everything still looks exactly the same as Pandas, except that we have this additional import lux statement. So what happens when we print out the data frame? Let's say we want to get a sense of like, what does my data look like? When I print out my data frame, what I get is the default Pandas table that is being shown to me. So these kind of highlight that there are rows and columns in the data sets. Each row in the data set corresponds to a country. Now, Lux also adds this additional toggle button, which allows me to go from the table view and toggle to a dashboard of visualizations that is recommended to the users. And this is super useful as a visual view of looking at your table. So these dashboards showcase things like correlations, so that all of the visualizations here are ranked based on ones that are most correlated to the ones that are least correlated. So you can see that these patterns are a lot more scattered. We could also take a look at all the univariate distribution. So these are all the attributes in my data sets, and these are ranked based on the ones that are most skewed to the ones that are more uniform and less skewed. We could also look at occurrences and even geographical maps showing some of the values that are within my data frame. And we can see that this is a very useful way to get very quick visual insights beyond what we're seeing with the default Pandas table view. And so let's say that we're looking at this data set and we notice that there's a very interesting relationship between the average life expectancy across different countries and its inequality index. In particular, there's kind of this negative correlation across these two variables. And so we think that this is kind of interesting. We want to learn more. And in Lux, there's this concept of a high level intent. So users can convey to Lux, hey, I'm interested in these variables. Show me something that is related to that. So the way that we express this in Lux is we would set df.intent equals to inequality and average life expectancy. So once we set this intent and we print out the data frame again, we get this default view that we see in Pandas. And then when we toggle to the visualizations, what we actually see is the visualization that is based on our intent. So the average life expectancy and inequality. Now, beyond this visualization, Lux also shows me all the ones that are related to this visualization. So for example, I can add an additional attribute. So adding a column to look at, how this distribution changes, how this relationship changes when whether a country is landlocked or not, whether a country is in a G10 country or not, maybe depending on the region. So I can add an additional column to look at how this visualization breaks down. The other thing I could look at is I can add an additional filter to what I've specified as the intent. So I can look at different subsets of the data. So for example, countries that are in the Middle East, countries that have 3 borders, or countries that have a specific number of official languages. So these are really interesting breakdowns of the current visualizations that I've specified. And then the final thing that you can kind of take a look at is you can take a step back and just look at the univariate distributions that are in my data set. So this high level intent is a very easy way for me to specify at high level, hey, I'm interested in these attributes, show me something that's interesting. And one of the things you probably already noticed is that Lux doesn't actually require any changes to your Pandas code. So what that means is that it makes it very easy to do data manipulation and visualizations all in the same environment. Whereas typically you might have to go to a separate BI tool or a charting tool like Excel or Tableau to be able to do the plots and then doing the cleaning, data cleaning and manipulation within your notebook. All of the Pandas API can be used as is in Lux. So here what I've done is I've loaded in a COVID data set, and I I joined it with my original data frame. And when I print out the DF again, we could see that those additional columns are being added and the visualizations are updated right away. So one of the interesting findings that I see is that when I look at my dashboards, there is a very interesting trend between sort of the stringency scores that is shown in this data set. And so let's say that I wanted to share this with a colleague. This is an interesting trend. So what I can do is I can click on this visualization and I can click on the export button on the top right-hand side. What this actually does is that it allows me to export this visualization into a programmatic variable. So I can access this variable by doing df.exported. And this is the same visualization that I've selected here. And this is really convenient now because I have programmatic access to this visualization, which means that I can actually print it out as code written in Altair or Matplotlib or Vega Lite. So right now, what I'm showing is the Matplotlib, the Altair code. And what I can then do is just copy and paste this into a different cell and be able to plot the exact same visualization that I saw in my dashboard. So this is super useful because sometimes maybe I want to make some tweaks to the visualization. Maybe I want to add an additional labels and titles. And this is, I can do all of that with the Altair code and then share this with a colleague. So that's at a very high level, how you can use Lux to go from a simple data frame, which you're working with in Pandas, to a set of visualizations that are recommended, all the way to visualization code that you can export and then send to a colleague. Okay. So going back to the talk, some of you might wonder, like, okay, how does Lux work? How is it actually, what is it actually doing underneath the hood? So for that, Lux is actually based on my dissertation work, where I've studied how to better design automated assistants that helps with data analysis and visual data exploration. And Lux is a culmination of that research into a tool that is lightweight, usable, and fits well within the Python and Jupyter ecosystem. So we've published a couple of papers on this topic. And so if you're interested in the details of how this is done underneath the hoods and some of the optimizations that we've developed to make this scalable, feel free to check out the paper at this link. So just to kind of recap, in the demo, we saw how a very typical data analysis workflow where we're working with data frames within the Jupyter notebook can be completely transformed by just adding a simple import statement. And with Lux, working with data frames suddenly now affords a lot more visual richness to encourage these meaningful exploration. And in particular, when we print out the data frames in Lux, Lux automatically recommends these visualizations essentially for free to the users, and providing an alternative way that the data frames can be visualized. And the visualization is always on in the sense that users can always toggle back and forth between these complementary views. And sometimes we find that there are tasks that are more amenable in this table view, whereas in other cases, the recommended visualizations might be more useful for getting a quick overview of the data set. We also saw in the demo how we're able to do this while preserving the exact same Pandas API and commands that you would typically use, which means that all the nice APIs or functionalities that you get from Pandas, we could still get in Lux without having to change a single line of code. And this also means that we don't have to move into a separate environment for data cleaning or transformation and visualizations. We also saw how data frames can be attached to an intent, which enriches the data frame with signals about how the visualizations should be displayed to the users. So users can specify at a very high level what they're interested in, and Lux automatically infers the underspecified details and determine the visualization mappings based on best practices. Finally, we also saw how the users can either export their entire data frame visualization into an interactive report. So Lux currently work with dashboarding tools like Panel or Streamlit, and some of the other tools that we saw earlier today. You can also, as we show in the demo, click on one or more visualizations and then export them as code. You can edit these code further in your Jupyter notebook. So Lux currently supports Vega Lite, Altair, and Matplotlib as the code that it generates. And so at this point, you're probably thinking, Lux is amazing. How do I get started? And to get started, you can follow the README on our GitHub page. And Lux is a simple one-line install that is available on pip and conda. You can also we follow the different setup instruction where we support various different notebook front ends, including Jupyter Lab, the classic Jupyter notebook, as well as VS Code. So to kind of recap, in this talk, we've seen how Lux is an automatic tool that supports visualization and discovery alongside a data frame workflow. And so we hope that this presentation gives you a taste of how Lux can help you enhance your data exploration experience in the notebook through a very low barrier way of working with visualizations. You can find the source code and the installation instructions on our GitHub page. Cool. And with that, I'm happy to take any questions with the remaining time.
Yeah, we've got someone with a couple. Okay, first one, what's the, oh, and another one popping in, awesome. We've got plenty of time, so feel free to ask away. What's the performance of Lux? Say if I have a data frame of 1,000 columns and 1 million rows.
Yeah, that's a really great question. And I sort of alluded to this in, oops, let me pull up this slide here. In sort of this research slide where we actually did a lot of work on making sure that the computation of the visualizations and all the things that is required for generating these recommendations is kept as a minimal overhead. So currently, like for medium to large data sets, there's still a couple seconds of like wait time, especially in the cases where there are these very wide tables, because you would imagine, for example, 1,000 columns, you would actually have to iterate over all of these different columns and combinations of them. So it quickly, the computation speed quickly sort of adds up. This particular paper that I mentioned, we've developed 3 optimization strategies, and we've actually shown some experiments on how it scales for these different numbers of rows and different numbers of columns. So I would highly encourage, if you're interested in looking at the scalability of this tool, to look at that paper.
All right, thank you. Second one from the same person. Another question, does Lux maintain state? If underlying data frame changes, will previous plots auto update?
Yeah, that's a really great question. So this is tied in with the idea that we don't necessarily compute the recommendations every single time as your data frame changes. This is one of the optimizations that we exploit. We only compute that when you print out the data frame. So when you request for the recommendations. So the plots do get updated, but only it's doing this in a very efficient way so that it doesn't have to constantly recompute if you're not printing out your data frame. There's a question around how do you compare this with something like Trifacta by Jason? So that's actually a really great question. I think that there's many of these questions around like, okay, how does this compare to a tool like Trifacta or Tableau or some of the other tools? I think Lux isn't intended to be a replacement of these tools. In like Trifacta and Tableau, they obviously have much richer support for these visual interactions and dashboarding capabilities. The goal of Lux is to kind of get you to these quick insights and then you can kind of delve in further. You could build a dashboard around it. So I see them as kind of a complementary tool instead of kind of a replacement for some of these graphical user interfaces or low code, no code tools.
All right. If you want to take any more, there's a, oh, now they're starting to roll in. On the technical side, are you monkey patching the data frame?
Yeah. So yeah, on the technical side, how this is actually done underneath the hoods is that Lux is monkey patching the Pandas data frame. And we actually have this internal object called the Lux data frame. And it essentially is a wrapper around the Pandas data frame in some sense. And this is something that we experimented quite a bit to figure out what is the best way to allow users to print out the data frame and then be able to get all the recommendations, but still preserve all the Pandas API and the ability to use that.
All right. I'll go ahead with just a couple more, if you don't mind. What can I do if I have a visualization in mind that isn't among the recommended charts? Export code, then modify it?
Yeah, that's a really great question. So the goal of Lux is, again, to get you to these initial visualizations, but we do have some customization capabilities related to creating additional tabs that you might be interested in seeing. We also have this very expressive language. We saw a little bit of that with the intent so that you can specify at a high level, hey, here are the columns that I'm interested in. And the Lux has an internal logic to help you generate the visualization that is relevant to those. So we actually have the capability of creating this visualization or collections of visualizations with that language without having to write too much code. So it's definitely something that's, if you're interested, we talk about this in our documentation. Happy to follow up with some of those links.
Oh yeah, it looks like everyone's brains are starting to get working now. And for sure, I think your work is really important because like one of the heavy themes of the conference promotion was ethics in AI. And for that, we need people like you to actually make the data understandable to everyone. But yeah, thank you very much. And everyone can follow up with you on the links you provide. Or
cool. Thank you so much.